Hello everyone, welcome to 1045 Engineering. We are here with yet another video in Grind 75, a Better Blind 75 coding series. Today's problem is on valid anagrams. Anagram is like you are given two set of strings, art and rat. Since both of them contain the same set of characters, ART, ART, it's an anagram. So let's jump into the problem statement directly and start solving. So, as of now, we have solved 6 problems in our Grind 75 coding series. Last one was with invert binary tree. Today's problem is valid anagrams. Let's start. So, for all of you who have not subscribed to the channel already, please subscribe to the channel. And in the comment section, if you get a better approach in the for the solution, please leave it in the comment section, and we can chat there. Okay, let's start. So given two strings s and t, return true if t is an anagram of s and false otherwise. An anagram is a word phrase formally rearranging the letters of a different word or phrase, typically using all the original letters exactly once. Okay, so we can understand this from the examples. So first string is anagram, second string is nagaram. Okay, second string is nagaram. If you see, it contains same set of characters n, which is available here as well, and then a is here as well, g is there, a, one more a is there, r is there, a, one more a is there, so 3 a's, m and m is available. Similarly, if we see for this one, rat, car, so c is not contained in the first string and t is not contained in the second string, so it's not an anagram. Okay, so before we start solving, please take a minute and think what would be the approach that we are going to take in today's problem. Okay, let's start. So the basic, so forget about solving the code. Let's see. There's a string which is already given to you, anagram. Now you'll go through this string and you'll find out whether this string is an anagram of this string. How can you do that? You can actually do it this way, so that n came and you can see if n was available in the other string or not. If it's true, you move forward. A came, you'll check whether a was available in the other string or not, right? Similarly, g will come and then a will come again. So one more thing is, you have to keep a check that if there are 3 a's, there has to be 3 a's in the earlier string as well, right? So one thing is for sure, we are going to traverse through the second string and compare it with the first one. That means we need to store all the characters of the first string. But now we should be aware of how many times a came, how many times n comes, how many times g, r and m, right? So what we can do is, first let's start with the base condition. Okay, base condition would be if length of two strings is not equal, return false, right? Because let's say it's of 7 characters, this one is of 8 characters, there's no chance that these can be an anagram of each other, right? So let's write the base condition first. If s dot length is not equal to t dot length, return return false, right? Now we need a data structure that will first store these characters from the first string, so that when we traverse the second string we can fetch it from the first string. We can actually use a set, hash set, but the problem with the hash set here would be that it does not store duplicate elements, so we need to go with hash map. The advantage would also be when we have to search that character in the original string, it can be done in log of n, the searching part. Okay, so let's go with store the, okay, before storing, let's first just create a hash map character. Okay, but what will we save next to it? Now since we are using a map and not a set, we can actually store the frequency of the characters. This way we will be aware that a had come thrice, n had come once, and similarly for the other characters. So we'll store first key as the character, value as integer. Map is equal to new hash map. Done. Now store characters of first string into the map with frequencies. Okay, so we'll say for int I equal to 0, I is less than s dot length I plus plus. Why traverse the first string s? Because of course one by one we'll go through the character and store them in the map. So we'll say map dot put. If some of you are not aware how a hash map works, please watch the videos. If I have one already, I'll put a link up there. Let's start. Okay, map dot put s dot caret I. So it is going to put the first character, which is a, as a key, and now for the value part we want to put its frequency. So when the a has come for the first time, the frequency would be 1, but when it comes for the second time, we want to put the frequency 2. But how do we know? So let's first search this character inside this map only, get the frequency, and then add one more to it, right? So we'll say map dot get or default. So get or default is helpful in case we are at the first a and it is not stored in the map already, so we'll give a default value of 0. But if it is stored when we are at second a, we'll get the first frequency, which is 1, add 1 to it, it will be 2. So we'll say get or default s dot caret I. We search for s dot caret I. 0 is our default value. In case a is already not available in our map, we'll store the frequency 0 with it. If it is available, we'll get that value and then we'll add plus 1 to it. Simple. So for the first a, we are storing 0 since it's not already available in our map. For the second time when the a comes, we'll get the value by get method. Frequency would be 1 for a, and then we'll increase it by 1 and store it again, right? Okay, so this way we'll store all the characters from the first string s. Now we will traverse the second string, and one by one we are going to search each character from the second string. Okay, we'll do the same again. For int I equal to 0, I is less than t dot length. Here I could have done s dot length as well, because both the lengths are equal. Since if they are not equal, it will enter the loop here and return false already. Okay, so first let's check. What do we want to check first? If the character is already available in the map, because if it is not available, we are simply going to return false, right? So we'll check if map dot contains key, and we'll pass t dot caret I. Okay, so first is n, and we are going to check if that character n is already, so we are saying t dot caret I is 0, so this gives us first character from the second string n. Is n already contained in this string? Then we are going to perform some action. But in case it is not available in this map, we will simply say return false. But it is available, and what happens when it is available? So for the case when it is already available, now comes the question of frequencies, right? So we want to check for the frequency also. So some way we need to reduce the frequency. So if map dot get or default t dot caret I, searching the same element I, so value 0 if it is not available is equal to 0. Since in the earlier version we were always storing each character with a default value of 0 as well, right? So we are going to check that now n has come. What if in the map we had reduced its frequency from 1 to 0? So n was available, but now n's frequency has been reduced, right? So let me come back to this part. Okay, I know this must be creating confusion in your head, but let's come back to this part. So if that frequency has reached 0, that means in our current map this first character from string t is not available. So we can simply say return false, right? If it's not so, we'll say m.put t.caret. Now we want to change the value. I map.get t.caret I, and what are we going to do here? -1. So let me give you one example before going forward. Let's say s looked something like this: AARM, and t looked something like this: ARM. Okay, now they are not anagrams because clearly, or let me give it more length. So the lengths are equal, we are okay, but they are not anagrams because a is once in the second string and it is twice in the first string. So let's say in our hash map we had already stored AARM, so we know a has a frequency 2, so it was stored something like this: a with frequency 2, r with frequency 1, m with frequency 1. This is for s, right? Now when we are traversing our t string here in this loop, what we are doing is first we are checking if the map contains this character. So we came at a. Does the map contain this character? Yes, a is available, right? So we enter the loop. Then we check if map.getOrDefault t.caret I is equal to 0. So if its frequency is 0, okay, I would like to reduce the frequency here, so let me make adjustment like this one. So if its frequency is 0, okay, it's difficult to understand the 0 frequency from here, but let me simplify it. Let's do it this way. Keep it a r m m and a r m. So now s will be stored something like this: a with the value 1, r with the value 1, and m with the value 2. Now we first check at our first character a. Is it contained in our map? Yes, a is available. We go inside, we check if map getOrDefault t.caret I 0 equal to 0. So this is for the default value, so you can actually think of it as map.get t.caret I equal to 0 if its value is 0 or not. No, its value is not 0, right? We are going, otherwise we would have returned false, so it does not enter this loop. Then we say map.put t.caret I, so we are adding another character to this t.caret I, which is a again, so a is already available, so it will stay like that. And the value is going to be map.get t.caret I, so we are getting the value from this original map, which is 1, and then reducing it by 1. So we are storing a value again in this as a0, so a is already available, value will get replaced to 0. Now frequency of a has reduced, so it will not enter the else part and loop will move forward. Now I reaches 1, again it is at second a. Now we are going to check if map.contains key t.caret I. So does this map contain a? Yes, map contains a, otherwise else false. So map contains a, we enter the first loop. Now we check if map getOrDefault, so we'll get the value for t.caret I. We'll fetch the value for this character a. The value is 0. That means this character was present but not with the same level of frequency, because this character was available only once, it was stored once. After the loop we reduced this value. Now we are checking for second A, and the second A is not available in this, so this will loop become true and will return false from here. Okay, I hope that made sense. And similarly, since it's returning false directly, it will be a false for this use case. It's not an anagram. Okay, let's quickly run our code and check. Oops, missing return statement. Okay, after all this, if our code still comes out of this, that means it is an anagram. Return true. Run. So just for the beautification, let's make it look like this. Okay, cool, it's working. Let's submit and check. Okay, the solution works. We can see it beats 20.74% of the users with Java. Let's submit it again for caching issues, if any. 17 milliseconds is a long time. Oh, this time 18 milliseconds. Okay, but can we improve it? Okay, let's look at the problem again. We have to traverse this first string, we have to store this first string, we have to go through this second string and find out whether each character was available in the same frequency in the previous string as well. We took the good approach with the hash map. So if we overall see the time complexity, if you go loop by loop, it will be O of n for this one, which is this length, then O of n here for this length, but inside it's a map search as well, so log n. So overall time complexity which is coming out is n log n for this solution. So is there a way we can solve it in O of n? Please pause the video, take time and think of a solution. Okay, I think everyone's ready. Let's start. So let's start solving this in O of n. Let's remove this piece of code. Okay, we are going to keep the base condition as it is. So because if lengths are unequal, it's not an anagram, right? Now what we will do is, a good solution could be, imagine it like this, that you create an array of all the characters A, B, C, D, E, F, G, H until Z. So A is there, then B is there, C is there, D is there, E is there, F is there, similarly Z, right? So you create a character array with all the characters from the alphabet, and now you pass through first string A N A R A N A G R A M, and what you do is, let's put A N G R A M as well. So earlier all the characters will have the default value with them as not by default value. You're just creating 26 characters representing A B C D E F G H. You don't have to store A B C D E F G H. But when you see A on the first value, you will write 1. Similarly, when you see all other values would be 0, 0, 0, 0, 0, 0, 0, right? Similarly, we are going to store for 26 characters. We see A, we make the first character as 1. We see N, so we go to nth place and make the character as 1. We see A again, we increase its value to 2. Similarly, for each of the character at its designated place, we increment its integer value by 1. So what would happen in the end is, A will have 3 characters here. Similarly, n is somewhere which has 1 character. Similarly, somewhere we'll find A, B, C, D, E, F, G. G will have 1, and similarly for R and M as well. Now we traverse this second string, and when we traverse, we reduce the integer value. So when we see n, we go to its nth position, and we reduce the value to 0. Similarly, we got A, we reduce the A's value by 1, it becomes 2. Next time we encounter another A, we reduce its, before that we encounter G, we reduce its value to 0. We encountered another A, we reduce its value by 1 again, and we encountered another A, we reduce its value by 1 again. This way, once we are done with the traversal and reducing the values, after that we'll run through this character array. We check if any value is non-zero. That means there is a character which was available in either of these strings but not in both, and that would mean it's not an anagram, right? If we understand it for this example, rat and cat, let's say they both have A, so the first value became 1, then it becomes 0, so it became 1. Then somewhere down the line we have R, so let's say for R also becomes 1, R as T, so then for T also it becomes 1, 1, and then similarly rest everywhere it's 0, right? R, this is representing A, this is R, this is T. Then we have C. C will make A, B, C, third one as 1, right? Then we came, so it will be reducing the value, so it becomes -1. Then we get A, its value reduces to 0. Then we get R, its value reduces to 0. Now when we traverse through this character array, we can see non-zero value here. That means not an anagram, right? Let's try and code this. Okay, so first we can assume that all the characters are in lowercase, so let's create an integer character array where we'll store all the character counts. Count is equal to new int of size 26, since there are 26 alphabets. Okay, now we'll do count character frequencies in string S, right? Because first we have to traverse the first string and increment the values. We'll say for char C from S dot to char array, and we'll say char count. Now if I say at the 0th position ++, I know that A is at the 0th position, but how would the program know that for which position we are going to do it? So actually there is an easy way to do this, is you can say character C, so C is name for this character. To remove the confusion, let me name it CH. Okay, so CH, so it's ASCII value because it's an integer array, CH minus the ASCII value of the character A. It will give us the base. So if CH is A minus A, ASCII value for A is I think 61. Let's check quickly. ASCII value of ASCII 65, right? And so we are saying 65 minus 65 is equal to 0. So at the 0th position in this character array, will increment the value, so ++, right? Similarly, when we get n and we search for the ASCII value of n, which is 110, and 110 minus 65, let's do quick math. So who can do it fast? Please comment. 110 minus 65, 75, 85, 95, 45. Oh, the ASCII value of n shouldn't be actually 69. 110, 111, 112, 113. Let's quickly go through the ASCII table. I know it's not necessary for the, okay, So sorry, ASCII value for the small a starts with 97 actually. So we are look at 97, and for n it is 110. 110 minus 97 is the 13th character. K is the 11th character, then 12, 13, 14th character, sorry. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14th character. So 110 minus 97. Right? Okay. So 110 minus 97 would be 13 here, because 0th position will be for A. 13th position in the array would mean the 14th position. 13th is the index. Right? So next time when we get an A, we get CH, which is 110 minus A 97, will give us the index 13, and will increment that value on the index 13th from 0 to 1. Okay, I hope this was clear. Let me just for everyone's understanding, let me just reiterate it. So what we are doing here is we are taking the character, their ASCII value. So for each of the character, small a starts from 97, then B is 98, then C is 99, and this way. So to calculate the index for the character, we are simply reducing 97 from this. So if you understand from B, A goes to 0th index, B would be 98 minus 97, so that is 1, so first index. Okay. So one by one we traverse this first string and we increment their positions by, so all the values, default integer values are 0 here, we increment those values by 1. Okay, so when A is coming 3 times, it is going to increase the 0th index by 3, right? Now we are going to do the same decrement. Okay, decrement character frequencies for string T. Okay, now we'll do it again for char ch T dot to char array, and now we are going to reduce the values for the contained characters. Char count, same thing, ch minus a minus minus, we are reducing the value by 1, increase by 1, decrease by 1. Okay, once this is done, we are going to run through our character array again and check if there is any value which is not equal to 0, then we'll return false, otherwise we'll return true. So for int count, which will come from char count, oops, what did I miss? Okay, char count, if count is not equal to 0, say return false. Otherwise, if everything goes fine, code reaches this stage, we'll say return true. Let's run it. Okay, let's submit and check. Okay, so now it's running in 1 milliseconds, beats 99.93% of users. Okay, I leave it up to you guys to please let me know what is the time complexity for this solution. Okay, that is all from today's episode in Grind 75 coding series. Thank you everyone. Let's meet you next time, and please like, share and subscribe. For any doubts, please let me know in the comment section. Thank you.